then the less than symbol, and then the code that you want to run against the database. So for this will be create employees.sql. Now in this case, we already have a table in this database called employees. So my guess is it's going to break and say that database that already exists. See that? Table employees already exists. Okay. The insert into would work though. We could maybe change the data that way. We're inserting in different employees. Let's do Sam and Sally and it's the same format. So SQLite 3, just like the same way it was Python 3, followed by the file name. This time it's SQLite 3, then the database, so Barbershop DB, then, is this pointing the right way? Yeah, it's pointing. So it's pointing towards the database, and then I want the name of the file. So that would be like this insert employees.sql. Okay. Employees has no column named hometown. Interesting. So name, so let's look at the error here. It looks like I guess I added that, but if you look at the table, we don't have hometown. So we should remove that. And now I have name, phone number, email. Those are the values I have, and name, phone number, email. So let's try this again. All right. And notice one other thing. When you don't see an error message, the chances are it ran successfully. So how would we check that? I would now go into the SQLite shell and connect to the database. So it'd be SQLite 3 followed by the name of the database. Now I press return, and notice you can see it says like SQLite now. So at this point, everything you type should be like a SQL command or a SQLite command. The SQLite commands are those things that begin with a dot. So like dot tables, right? Dot schema, we saw. Those are like the SQLite commands. Eventually, so they're just particular to this tool. The SQL commands, like all databases, are essentially using the same commands. And that would be like this create table command, the insert into command. Those are all SQL commands. And for instance, we want to say select all from employees, like select all the columns and all the records from the employees table, semicolon. We can see that, all right, it did run our code. So we saw, one way to run our code in SQL was from the shell, right, from bash, from the command line, meaning I would have to exit out of this by doing .exit, and now you can run the code when I'm in bash, right? I'm not in SQLite anymore. Okay, that's one way to do it. The other way to run like any SQL is just simply to connect to the database, and then for instance, let's do Marge and Lisa. We'll just insert in some more data, and you can just copy. That didn't work. You can just copy the command directly into the shell, the SQLite shell, and make sure you have the semicolon there, and then press return. And now we can see if that worked, right? Select all from employees, and we should see, so you can see that did work because we have Marge and Lisa there. All right, so you have this option as to whether or not you want to connect to the shell, and make sure you do that while connecting to the database as well, and then run your commands, or you can write it in a file and do it that way. Questions about any of that so far? No? All right, so then there's another way we can do it. We can connect to the database. So notice one thing, which is that the Barbershop DB, it's a file. Like in SQLite, the database is a file. So you have to make sure you're in the right directory when you're connecting to it. If you're not, it's going to create like a second database with the same name in a different directory. The same way like you can create the same named file in different directories. This is just a file. So another way that we can let's say we'll create a new database. We'll do this with, let me do it in Colab. And this time we'll use like the SQLite 3 library. So let's do Colab, File, New Notebook. All right. So for the SQLite 3 library, this is a Python library. So you can install it with like pip3 install SQLite 3. I guess I'm lying.
For me, it was already included, so I didn't even have to do that.
Okay.
Just so you know.
Let's try that. So we do Python 3. I should be able to maybe import. Is this SQLite 3? Yeah. So we can see, we can just automatically, it seems like, import SQLite 3. And you can do the same thing in the Colab. Import SQLite 3. And basically, we're going to do the same steps that we did through the command line. So the first step is, connect to the database. So here, we connected to the database by doing SQLite 3 barbershop DB or whatever. Here, I guess we'll do like a SolidWorks type place. So here we'll do SQLite 3 dot connect with the name of the database, SolidWorks. And then we call this the connection. And then the next thing we can do is, if you think about the next step, it was then to probably try to create a table, right? Create a table. So to do that, this is a little confusing. This is your connection to the database, but to actually run like a command like create table or insert into, you need to have this thing called a cursor. And the way you create one is by doing connection.cursor. So you see that this created a cursor. A cursor, you can think of the cursor as like this little line, this little arrow here, like this is my cursor. And you probably want to assign it to a variable. And then what you can do is cursor.execute. Let's write a SQL, and you just write a SQL command. So like create table, employees, then the column name text, hometown is also text. And then I think that's it, and then semicolon. Let's see. So now we'll run this, and we'll go through these steps again. And then finally, I'm going to have to do connection.commit. All right, we did it successfully. Let's just make sure. We'll do one last thing to check this. So we'll do cursor.execute, select all from employees, and finally cursor.fetch all. And like I said, we'll review all this. Okay, so we just confirmed that we can make a select statement to this table, and it's just that there's no data in here. But if this earlier thing didn't work and there was no table called employees, for instance, like if we try like foobar, see that? It breaks. It says no such table foobar. So we know that we must have been successful here. All right, so what did we do? We imported the SQLite 3 library. We connected to our database, even though this thing didn't exist yet, right? And then we created a cursor. A cursor is how we will like run our commands, okay? This is like a cursor object. It's like and it has a method on it called execute. So we're saying, okay, cursor, I want you to execute this employees, create this employees table. The cursor is connected to the database, right? It's coming from this database. So it knows that, hey, I want you to do this against this database right here. Now, whenever you write code that changes something, for example, creating a table, inserting data, like deleting data, you have to then run connection.commit, as in, hey, I really want you to make this change. If you write code, however, that does not change anything, like retrieve, but it rather is a select statement, like retrieve data, then you don't have to do the commit afterwards because there's nothing dangerous about it. You're not asking to change anything. You're just asking to read data. So if we do select all from employees, afterwards, I don't have to do connection.commit. Instead, I do cursor, fetch all means like give me all the results. Like you just ran this, you just asked for this, but I actually want to see all the results. So it's a little cumbersome, I guess. Like it feels like more steps than maybe it needs to be, but this is the library. This is the way they set it up. So the summary is essentially when you make changes, you need to do connection. You always run the command with cursor.execute, but then when you actually, if it's something that makes a change in the database, it's connection.commit. If it's something that's a select statement, it's generally you'll just do cursor.fetch all. Show me all the results. I can go through another example of this, but any questions before I do? All right, so let's insert some data. So we're going to insert some data. Think about what we'll have to do. So one is we'll do cursor.execute, right? Because the command always is .execute. And then the other thing is, I don't know if I've shown you this before. This is just a string, these 3 quotes. But if you want to use a multi-line string, you use 3 quotes on each side. It won't work if you just do single quotes and you want it to be multiple lines. But if you do triple quotes, it works. And I think this works with either single quotes or double quotes, whatever you prefer. Okay. So now we'll do insert into employees. Then we need to specify the columns, which is name and hometown. Right? And then we do values. So this is what we'll insert into. And now we'll say the values will be, Fred again. Sorry, this is so lame. And then New York City. And then, Sam and Chicago.
Jeff, is it a best practice to write this reserved word in capital, like insert into and then values?
There was actually a debate about it. I don't know why, but people have their preferences. I don't care either way,
Sure.
Yeah.
Oh, sorry, could you explain again where you're using triple quotes?
Yeah, so triple quotes is it is for a multi-line string. So generally,
Oh, okay, got it.
yeah. So I'll do that because, well, for a couple of reasons. One, because you have you don't want to confuse it with these inner quotation marks here, right? So that's one thing. Actually, I don't think this. So I think we're good here because there's no triple quotes. And then 2, you just don't want to write a SQL statement all in one line, probably, or at least not an insert into statement. So okay, I should probably have a semicolon at the end. One thing to note is you're not going to see your error. Let's say I did this. This is a problem, right? Because I have a comma instead of a semicolon. You won't see it. I wonder if I'll see it now. Oh, you do have it. Okay, that was actually useful. So this is incomplete input, maybe because of this comma, and what I should have really is a semicolon. Cursor.execute. It looks okay. Okay, so that seemed to have run fine. And now let's do, what's the next thing? This is changing the database, right? Right, it's inserting in data. My database will look different than afterwards. So what we have to do next is connection.commit, right? Because we're making a change. Notice again, you don't see any feedback that it worked. The only way you can check is you would make another query to the database and say something like select all from employees. I don't think I need a semicolon here. It's probably best to do it just in case. And now we'll do cursor.fetch all. Right? So it runs it. It doesn't actually show you the results. You have to say I really want to see these results. And here now you can see what comes back. It's still our outer list, but it's a list of tuples. All right. Okay. In the so there's a reading and a little lab on this. In the lab, you'll see that we do this an easier way, and I think you'll probably get used to this, which is You can also read a pandas data frame. Let me show you this. So here I have a CSV file, like on GitHub. All right, you can kind of see. All right, so I have this CSV file on GitHub, meaning it's comma separated values, and what we can do, yeah. So I'm reading from it, right? I think you've seen this before, and then I have my data frame. Now, what's nice with pandas is we can kind of create our new database, so we call this Salad Shop DB, and then we can call this employees DF or ingredients DF, whatever it is, ingredients DF to SQL, and then the name of the table. So in this case, it'll be ingredients, and pass through our connection to the database. So now we're basically asking pandas to please create a table called ingredients, and it knows it should have these columns, and also insert into the table this data. All right, so now we'll do this. That seems to have worked. Then we can check if it worked by doing pd read SQL, and then it'll be select all from ingredients. And again, but we need to say like what the database is. So I think we have to pass through the connection as a second argument. You see that? And this is reading from our database. So this is like everything's the same except the inserting into and the creating of the table, right? That's a little bit faster. Like Pandas is trying to help you out with that. So like just to like quickly load up some data and then being able to work with it, like last times in the labs, we will do that rather than the cumbersome process you saw earlier. All right, it also looks a little nicer just like having these column names here and getting back a data frame as opposed to, you can see what we got before is just like a list of tuples, right? By doing cursor.execute and then cursor.fetch all. Right, so this one's just more work, I guess, to do. We will be using this, so like later so it is worth knowing. This one, but if you feel like using this one a little bit more, like later on, that's fine. So you could do pd.read SQL and use like the pandas library, passing through the connection object, or you can do, cursor.execute, select all from employees, cursor.fetch all to see the results. Okay. All right. Questions about any of this? You feel all right? Okay. So what I'll do, I'll deploy, the Python SQL. So this is the reading. Here's the lab. I'll also deploy these two if you want to go ahead. And then we'll have a lecture on select statements and limiting in order. Okay? So we'll do that afterwards. I did see like just a couple of questions about, what's going on here. So remember, here we're just reading in data from a CSV, right? And at this point, we have a data frame. Then down here, this is the same code that we saw before, right? We're connecting to a database. So we're importing SQL A3 library. Say, let's connect to this database. The database, if you want to look at it, you see that? It's just a file, again, like in your Colab. And then here, let's take a look at this. So you have your employee's data frame, right? It just lives in memory. Like it doesn't live stored on the disk. I think until you do. So when you read it, it just lives in memory. Then what you'll do is, and I'll rarely do this in the labs for you, but you can do to SQL, and then it's the name of the, so you think about it, it's this data frame, the name of the table, so in this case we'll call it like employees, comma, a connection to the database. And you can start to see that, right? Like it tells you, see the arguments, the name, then the connection. Then you can also see this thing, so watch. So to SQL, connection to the database. So basically what we're saying, this is going to do two things. One, it will create a new table called employees, right? So we'll do that create table command. And then after that, it will do the insert into. And I think what I had to do was I did index equals false, so it didn't create like this ID column or something. I think and you can see this. It says table employees already exists. There is an argument for like if exists equals like replace. So basically, if the table already exists, replace it in the database. So you can do that. So once you store it in the database, then the next thing is pd.read SQL. And here is where you put your SQL statement.
Jeff, I have a quick question here before you go. So with the collab, where does the database exist? I mean, if we close this session, the database will also disappear, right?
Yeah, it will disappear. It exists on one of Google's computers.
If I close this notebook
It will
and
disappear.
restart again, so my database will be there or not?
No,
there?
it will disappear.
Okay, thanks.
Yes. So then we do pd read SQL and like select all from the table, right? So from employees, like any SQL command you can run here as the first argument, and then you just pass through the connection to the database. So I'm like reading this data from this database. Or maybe a better way to put it is like this is the command I'm issuing or I'm executing against this database, right? All right. So, it is sometimes useful to think about, in terms of reading data from SQL. So far, I've been doing select star from employees, and the star means all of the columns, okay? So if you just want to do, specific columns, you can do like select name, comma, position. So it's just basically comma separated column names. So select name, comma, position from the table. So it's like selects is the keyword we're always going to do, and then from which table name. So from employees, and then here we're specifying what are the columns, okay? So select name and position from employees, all right, from the table. Right, if we want to do all of them, we can just do the star again, and that will give us back all of them. The other thing you can do is you can order the data, right? So I can say like order by zip code. So if I do order by zip code, I think it will be ascending by default. So you see this 1, all the zeros 1, then 2, then 3, then we have 11, right? And you can, so by default it's ascending, but you can, if you want it to be descending, so 1, you can specify it, that should be ascending with ASC. And if you want it to be descending, meaning highest numbers to lowest numbers, or highest values to lowest values, you can just put DESC afterwards. So now it's ordered descending. All right. So basically with SQL, you just kind of slowly build your queries, and you can always just kind of start small and then tack it on. So we did, select, if you think about it, it's like first we started with selecting all the data from a table, from the employees table. Then the next step was we're reordering that data. And then after that data is ordered, you may think about limit. Like limit to means limit to the first 2 rows. So here it would be Vanessa, like the order of operations is going to be select the data from employees, order by the zip code, and then limit to the first 2 rows that are reordered. You see that? So that's why Vanessa is coming first. If I change what I'm ordering by, let's make it more clear. Let's order by the name, ascending. So we should see Allison show up pretty early. There you go. So you see that? So it's reordering first, and then the last thing it's doing is limiting to the specified number of rows. And you can start to see that. Yeah, go ahead.
Is this just for practice purpose? Because the same thing we can do with the pandas. So first we are loading the data into data frame, then converting into SQL.
Right. But I mean, yeah, it's for it. I mean, the whole course kind of, yeah. But I'd say like you're gonna. I mean, you're gonna want to store the data in a database ultimately. You know, like especially like I said when we get to like relational queries. So yeah, like for this, don't use pandas commands to make the queries and to do that. Use SQL commands, right? Because you know that's the like honestly out of all the skills and like data engineering, SQL is probably the most important and the most asked for skill. So absolutely
Okay,
do
thank you.
this. Yeah. All right. So what do we get so far? So one, you can kind of see really the we're loading. I'm starting to emphasize like some of the order of operations. So this is loading the data from the table, then we're ordering, and then order by name, order by what column you want to order by. So here name, and then it's finally is the limit. Actually, after this, you can think about the very end is actually this is like the view. This what columns do you see? For instance, if I just do like name and position, really everything is the same. All this, everything's going to be the same. We're just going to only see 2 columns, you know? See that? So everything's essentially the same. The query is the same. It's just like the last step is what do we want to show you? All right. So this, what occurs after the select statement between select and from is actually the last step with SQL. Okay. So we kind of saw a few different commands or a few different SQL commands. So we started with just like select column names from the table name. Then we saw the order by, and you can specify any column here, right? And it takes an optional argument of from lowest to highest or from highest to lowest. So if I do descending here, then we'll see here's Vanessa and Tom because V comes after T, right? And then finally stop after 2. But we can, like I said, sometimes you might want to just build up to this. Like that's what I recommend doing. So let's do it one more. Let's do select all from employees. Let's say we want to just get the people that started the, let's say the earliest. So the earliest means they'll have the lowest start date, okay? So we want to find the person who started, the first 2 people who started the earliest. What would we do? So we'll do pd.readSQL. Here goes my SQL query, and then here's my connection to the database. Then in here is where I'll actually put my command. So I want to find the person who started the earliest, right? So I'm just going to start with select all from employees. Okay? And then if I want to get the first 2 people that started the earliest, we'll order by the start date. So order by is 2 words. And we'll order by the start date ascending, right? Because we want to go lowest to highest. And maybe we'll just press shift return here. And I'm just going to confirm, okay, May is before November, is before the rest of these. And then finally do the limit too. All right, and then you can build onto it from there. Select just the names of the employees, right?
Jeff, do you always have to specify ascending or descending? Does it default to one of them?
Yeah, it defaults to ascending. So you can see if we don't do this ASC, we should still get the same values because we'll get the smaller number followed by the highest. See that? So smallest. So it's always the same.
So right now it's doing the ascending by month only, right? Not by the date.
No, by the date.
Okay.
Yeah.
So
You
by
can
the
see
date.
2019, 2020 is at the end, right? But the month is smaller.
Okay, got it.
Those are strings, right? That's the
I'm not sure.
select.
It could be a string. I'm not sure. I think it probably is a string. For here, it will be the same answer regardless. But my guess is this actually is a string. There are ways to go from pandas to SQL and like enforce the data types. We won't have to do it. It would kind of take us down a little bit of a detour because it would go into pandas, not to SQL, which I don't want to do. But yeah, in this case, I believe this is a string, but we get the same answer. Okay. All right. So far we just saw like kind of three things, like select all the columns. This is all the columns from the employees table. We saw order by, and then we also saw, like limit. The next thing I want to talk about is just group by, or like how to do aggregates. So if you don't specify, if you just say, let's say I want to find the max start date, okay? What SQL will assume is you mean of all the data, right? Of all the rows here, what is the largest start date? So it should be this 2020, I think, right? So we got this 2020, January 4th. So let's do another one. Let's say we do like the max zip code. Again, it's just going to be one row that's returned because there's only one maximum value. So select max zip code. All right, and that will be like this one, it seems like. I probably need a connection. Select max zip code from employees. It says max, no such column, zip code. I think I need an underscore. Yeah. Okay. So here it's just returning to you. One thing to note is it's just returning the row, in this case, that has the maximum zip code. So it's not going to return any other rows. All right. So like for me, when I'm doing aggregates, I always want to think about like how many rows are returned. If you do something like max, min, the average. So let's say like the average, and that doesn't really make sense. Let's do the minimum zip code. Again, there's only one minimum. So I guess it'll be this one. Only one row will be returned. All right. Okay. So this is, when we do the aggregates, by default, it's doing this across all of the data. Now, oftentimes what you want to know, however, is maybe you want to know, like for each position, what was the earliest start date? Or, yeah, like for each, or maybe for each zip code, let's do that one. For each zip code, what was the earliest start date? So I'm going to write out the query. So it'll be like select the minimum start date from employees and then group by the position. So, and I'm not just going to do the minimum start date. I'm going to do position, comma, minimum start date. So let's just see that. So again, I think the key thing is to think about how many rows are returned. And I'm going to go into more details about this. But notice what we're getting back, because we're grouping by position, in this case we get one row for each position. And what we're getting is we're getting the lowest start date for each position. So clerk, I think there might only be one, 2019, November 14. Salad maker, there's two, and the earliest one is 2019, 12. So you see that? So we just get one here, one value here, and this is the minimum start date, is right here. So this is how I would visualize group by is, right, well, let's do the same thing again. So the first question we said is, what is the earliest start date for each position, right? And we translated that into select minimum start date, comma, or really position, comma, minimum start date from the employees table, group by what? Group by the position. So in other words, what if we want to know the earliest start date for each position, then we're asking, we want one row for each position, okay? And what you can imagine happening, this is what I imagine happening, is first SQL is putting the code, the data into piles. So here's my position of manager. There's one guy here. Salad maker, there's two, right? And then we have delivery driver. This is in another pile. And then finally clerk. So so the group by really occurs first, okay? Then it calculates the minimum start date. So here it would be 2019. Here it's 2019 11/14. Here there's this one and then this one, and then it finally selects that data. So we're getting one row per each group. So for this row, for the salad maker row, it would be salad maker 2019. For this one, it would be manager 2019, right? And then delivery driver 2019, and then clerk. And the order, we're not specifying like the order of these rows. We can cover that later, but for right now, you can see the main thing is we are only getting one row back for each position, because that's what we're grouping by. And then it's calculating the minimum, or whatever that aggregate function is, across each of them. All right? Because there's only one value for a position, because this is always consistent, like manager, salad maker, clerk, delivery driver, right? There's only one. There's not, if we did name, it would be messed up, because there's two different values here. But here, because we're grouping by position, we're always going to have the same name. We can also kind of select based on that group by value. So let's just see what we got. So this is the same thing. If we do select position, minimum start date from employees, group by position, again we get four different rows back. Salad maker is this 2019 December 4th, and that's because we first group by the position, and then we calculate the minimum. Yeah. So the key thing, like with group by, is it's changing the number of rows. We started with 5 rows. We're ending with 4 rows, 1 row for each position. Okay? So it puts it into groups, then it performs the calculation. Questions about that? Let's just show a couple more. We'll move on to a different thing. We can do this Yelp data. So I'm just loading some data from Yelp. You can see that I have let's see, pd.readsql. If we want to look at all the data, select all from restaurants, table, limit 5 or 10. Okay, so I like to do like a limit just to see like, all right, let's just see some sample data here. And I need to pass through my connection. We can see the error as it says I'm missing one argument of the connection. So my connection is actually called the Yelp DB, right? Because that's what I'm assigning the connection as. All right, so this is our data. If we want to get, say, like the average rating per city, where city are these different boroughs, these different New York City boroughs. Let's think about what we want to do. I always think of like select all. I don't worry about this yet, but select all from restaurants. We want the average rating per city. So we want to group by, we want 1 row for each city. So that's what we want to group by, is group by the city. Then we can think of like the average of the rating is one thing we want to see. And then the next thing we want to see maybe is actually also the name of that city. All right. So let's try this. So select the city and the average rating from restaurants and group by the city. So if you think about it, the order of operations is first take all our data, put it into piles, 1 pile for each city. Kind of the same thing we did here, 1 pile for each city. Then calculate the average. So let's see that. Sorry. It is here. Okay, select city. And the main thing I'm looking at is, like, do we have 1 row for each city? Right, and you can see that we do. Everything else happens, like you can organize this data, like you can kind of add on more commands afterwards, but it all happens after the group by. So the group by is where like for instance, if you do, let's say order by city descending, right? The average, it will still be grouped by the same thing. These results will kind of be the same. It would just be reordered. It's just going to reorder this now with with Yonkers first, because I'm ordering by the city descending. So the order of operations still is to do the group by first and then order by the city descending. Then order these results. Okay. Any questions before moving on from this? So you want to specify what are you grouping by? Go ahead.
What if I want to select more column than city and average?
That's interesting. All right. SQL will let you do it. So let's go back to PD read SQL. Let's just look at the data again. Select all from restaurants, limit to, and then we'll do, this is YelpDB is the name of my connection. So I just want to look at some data. Okay, so the question is, what if I want to select more columns? Now, you have to kind of be a little careful with how to do it, especially with SQLite. Because let's say you want to select the category. You can do it. Sorry, this should be category. So here I'm selecting this. I'm grouping by the city. Now, the results are not going to make any sense. It does give you a result, but this is kind of messed up. What it's doing is it's putting in the groups, like if you it's putting in a group, and then it's just choosing the first kind of value on top. I know that this is a little confusing. So for instance, it is, in this case, sorry about this, let me move this over. All right, so if you choose this category thing, it makes no sense, because in this one, when I'm grouping by city, you have to imagine there's like 30 different records in this one group. So how can there just be one category American in all of Yonkers, right? There's not. But what it's doing is it's looking at that pile of 30 records, and then it's just taking the value, the category of the first one, and showing it to you. And this is kind of almost like a bug of SQLite. With Postgres, it won't even allow you to do this, because it will tell you, hey, like these categories aren't going to be consistent. So your only options, if you do a group by, is either to show the column that you are grouping by, right? Because it's all going to have the same value. If I put in a group of each city, each of those city names are going to be the same. And you get to choose an aggregate, right? So I can do the average rating in this case, and you could do there's no other kind of aggregates that make sense, but you could imagine if there was like the date, like you could do like the minimum date. So for each, let's say for each restaurant, you want to find out what is the average rating, comma, what is the earliest day that we opened up a restaurant in the Bronx or something like that, or blah, blah, blah. So basically, when you're doing a group by and you're selecting multiple columns, each of these columns should be either an aggregate, right? Or the column that you are grouping by.
What if you wanted to group all of the American restaurants in Yonkers and all the Japanese restaurants in Yonkers? You see what I'm saying?
Yeah, I do. You can do that. You can do group by city, comma, category. And now you can do select city category. And what will this do? This will kind of do what William was saying, which is Bronx, pubs will be one grouping. And we would now be calculating the average of Bronx pubs, right? Let's see that. So you see that? Now we have Yonkers American 3.5, Yonkers Bars 4.0. But that's a little fancier. Let's hold off on that for now. Okay, so the main thing I want you guys to get is when you do the group by, you're putting the data into piles. One pile of rows for each city in this case, because I'm grouping by city. And then we're calculating some sort of aggregate across that pile. So we're taking a pile of all the Yonkers rows, and then we're saying, okay, what's the average of these rows? What's the average of the Woodside rows? What's the average of these rows? All right. So that's the way that you think about it.
We can use a where clause also, right?
Yes.
With the
Yeah. That's the next thing I'm going to get to.
Oh, okay.
So let's do this. Let's say you want to. Yeah. Okay. Let's say you want to find just the cities now that have an average rating above, I guess above like 3.8. All right, so above 3.8. If you try so first of all, I don't like the fact that this is like average parentheses rating. I'm going to use what's called an alias. So I'm going to say as average rating. So what you're doing is you're kind of like renaming this resulting column to be this word. Right? And I'm just using the word as, and then I'm specifying what I want to rename this to be. So you can see that now it says average rating. And now it seems like I should be able to do this. I should be able to say where average rating is greater than 3.8, and that this is going to break. All right, so let's see it break. Okay. So it says, it's basically saying we have this problem with where. And the problem right now is the order of operations, which is where occurs before the group by. So if we think about this, so far we are selecting all our data, selecting data from restaurants, right? So, or loading up all our records from restaurants, putting them into groups, right? Grouping by the city, and then performing the calculation. And at that point, now trying to say where this calculated, for each of these groups, we have a rating above 3.8. Unfortunately, the where occurs before group by. So you have to tell SQL to wait until after performing the group by to then filter out the data. And the way that you do that is with having. So I'm going to have to say having an average rating greater than 3.8. And it breaks. Order by. It might be this order. It's probably the order by. There you go. Yeah. So the order that you put each of these clauses really matters. And I had the order by clause before the having. So I can say having an average rating of 3.8, order by the name of the city descending or something like that, and that will work. So you can see all these values are over 3.8. So the thing is, if I want to filter by an aggregate, you have to use the having clause. Now, what if I want? Okay, so that's kind of step one. Let's maybe see one more example of that. So let's use triple quotes here, so we can do this multi-lines. All right, so let's do one more. This time we'll group by the category. Select all from restaurants. So I always start with this, right? And then we'll group by the category. So we should get one row for each category. And then we'll say, give me the category, because we know each of them will be consistent for each pile, for each group. And then we also want the average or the rating, okay? And then let's do having a rating less than, that might be, let's keep it positive, having a rating greater than 3.9. And it broke it because I need an argument for the connection. So that's called the Yelp DB, I believe. All right, so we can see all these guys did this. One other thing we can do is, we can do a count. Like we can say, okay, like 4.0, maybe we're a little suspicious of that. Let's say, and a count of Oh, this should be, sorry about that, guy. This should not be rating. This should be as average rating, where the average rating is over 3.9. All right, that looks better, right? And now okay, so that all worked. So we used the having clause, over 3.9. One more example, if we could say in the count, so if I could do a count, this is going to be the count, the amount per group. And normally, notice that you can specify a column here, like the count of maybe like the name of the restaurant. But normally what you'll do is you'll do count star, because this, this ensures that really like if you have one column, you should have the rest of the columns. Like if you have the name, you should have the address, etc. So you'll say like, hey, I don't really care specifically about the name. What I really want is the number of rows, and to do that, to specify like, kind of like the entire row, is count star, and we'll do this as count. So let's just do that again. So you can see that some of these categories only have one row, all right? Probably because we just have a weak data set, and we'll say like, and having an average rating over 3.9, and the count, let's say greater than 10, and I think that will be good. All right, so this is a little bit better. All right, so what's the point? The point is when we are filtering based on an aggregate, you want to use having. All right, now let's say something else. Let's say that we want to, this is the average rating, right? What are we calculating here? We're calculating the average rating of restaurants across all of New York City, right? We saw like Bronx and Queens, etc. But what if we only care about restaurants in Manhattan? In that case, what do we want to do? We want to first limit all of our data down to Manhattan. Then we want to, of these resulting restaurants, put it into groups of by the category, right? So in this case, we want to limit our data before we put this into groups. Like we want our data set only to include just those records in Manhattan. So in this case, it's not about the aggregate either. It's about eliminating some of our records, eliminating some of our restaurants, not about eliminating these rows, bakeries, Brazilian, but eliminating the restaurants themselves. So that means we should probably use a where clause, right? So think about this. It's like select all. Let's maybe start from the beginning. So you can think select all from restaurants, where the neighborhood, is that what it's called? The city equals Manhattan. So now we just have Manhattan restaurants. Then we can group by the category, right? And now what are we going to get? We're going to get one pile for each category, but only considering restaurants in Manhattan. So we'll say category, comma, average rating, group by category. I think that's probably good. Okay, so this is really weird. I guess we only have 3 categories in Manhattan. Let's take a look. Select category where the city equals Manhattan. Let's
You can count it, I think. We can count the category. Like how many?
Yeah, you can do that. Count star. See how many. That's really weird. Maybe Manhattan is not how they want it. Let's see. Select all from restaurants. Let's do where city. Let's just do where city was Manhattan, and let's take out these. So we're just selecting restaurants where the city was Manhattan. Oh look, there's only like 4 or 5 records. That's weird.
Yeah, they were like, I saw one of the names for the neighborhood was Astoria, so I think that they are weird with like what's a neighborhood, what's a city, what's a, like, they just
All right, so let's do the Bronx. So the point is we're limiting the data before we do the group by, right? We're only considering the Bronx data. Now we're going to put into groups, right? Group by the category. And then from there, we want to see the category and let's see the count star. So what is this? This is for the Bronx. How many restaurants are there for each category? Okay. And then if you want, you can say, now if we say as count, we can say, now if we want to say, let's do only those categories that have a higher amount than 20, well, or let's say than 15, then that will be a halving, right? Because now this is on the aggregate. Having a count greater than 15. So this was a pretty so that's the result. So what is the point? The point is the difference between where and having. Where is limiting your original data, right? One record for each restaurant. Once you do a group by, you're no longer working with your original data. You're working with one row for each category, one row for each city, whatever, right? And having is about filtering based on the groups. Where is about filtering based on the original data. Cool?
So now we are using the having on the aggregate function, right?
Mm-hmm.
What if I just want to use having category equal to Chinese or burgers? It will work like that, or it's just going to having is only.
It would work like that. I mean, you could do. I mean, it's going to be filtering based on the on this row, right? So you could say, having category having category, capital C, equal to. I need single quotes. Equal to barbecue, right? And that will be because you can kind of see it, right? Like this is the table we're working with now after the group by, and having should be on barbecue now. So there it is. So you just have to think about like the transformation, right? Like if you're doing having, it's on this. Another way to think about it is just execute it and you can see it. It's like this is my new table. Like we started off with one row for every restaurant. Once we did group by, the result is one row for every category. And now if you want to filter these rows, then you use having. All right? Cool. Okay. I think I'm going to let you all practice this. So we will, and it just takes, seeing it a little bit. So I'll deploy these lessons. If you haven't gotten to this yet, do this first. Take your time, and then we'll move on to this section on aggregates and group by.